Okay, hello everyone. In a new video, so we have reached part 4 of chapter 3, which is the chapter of velocity for grade 8 students. Now in this part we are going to solve some exercises on what we have explained previously. Then exercise number 9, page 64. So Felix Baumgartner's free fall. On October 14, 2012, Felix Baumgartner made a historic jump after flying in a helium balloon into the stratosphere over New Mexico. His first jump was a free fall, parachute closed. During this fall, he reached a maximum speed of 1357.6 kilometers per hour. So let me say that the maximum speed denoted by V for Felix is equal to 1357.6 kilometers per hour. Just 1 second. Then they are telling me during his jump, did Felix Baumgartner reach a supersonic speed, a speed faster than the speed of sound to justify? Given that the speed of sound in air is v, sound is equal to 340 meters per second. So we are asked to determine whether Felix reached a supersonic speed. So he reaches a supersonic speed if his speed is greater than the speed of sound. So in other words, we need to compare these two speeds. So notice that Vf is expressed in kilometers per hour and the speed of sound is given by meter per second. So we know that in physics we cannot compare quantities unless they have the same unit. So let's convert the maximum speed of Felix into the SI. So in order to convert from kilometers per hour to meters per second, we simply divide by 3.6. Then 1357.6 divided by 3.6, this is equal to 377.11 meters per second. So now that we have the speed of Felix is given, the maximum speed is given by 377.11 meters per second, and the speed of sound is given by 340 meters per second. And by compare, we need to say if Vf is greater than Vs, equal to or smaller than. In this case, Vf is greater than Vs. Now, because the speed of Felix, since the maximum speed of Felix is greater than that of sound, and whenever his speed is greater than the speed of sound, then Felix reached a supersonic speed. So this is it for number 9. Now for number 10, they are telling the fastest elevator in the world, page 64. The Japanese industrial conglomerate Hitachi claimed to have developed the fastest elevator in the world. It's capable of going up 100 floors. The height of each floor is equal to 4 meters. So the distance d is equal to 100 floors. Knowing that each floor is equal to 4 meters, then 4 multiplied by 100 is equal to 400 meters. So the distance of 100 floors is given by 400 meters with an average speed of 10 meters per second. Now before I proceed in the question, Notice that whenever we have distance Vm, we can calculate the duration delta t using Vm is equal to d divided by delta t. Now they are telling me calculate the time taken, so here by the time taken, they are asking me about the duration delta t by the elevator to travel 100 floors. So we know that Vm, d and the duration are related via the following formula. Knowing that we are interested in determining delta t, so constructing the triangle of this formula, here because we have divide, then Vm will be at the bottom, d at the top, delta t here. Putting our hand over delta t, then the duration delta t is given by d divided by Vm. The value of d is given by 400. The value of Vm is given by 10. Plugging this fraction on the calculator, then the duration is given by 40. Since d and Vm are expressed in the SI, so the value of delta t will be in the SI, which is seconds. So delta t is equal to 40 seconds. What does this represent? So for example, going from the ground floor to the 100th floor, so using this elevator, it takes us a time interval or a duration given by 40 seconds. So indeed, this elevator is very fast. Now in number 11, they are telling me calculating durations, page 65. The title of this exercise is calculating durations. After finishing their work, Mr. and Mrs. Robinson leave the office at the same time. To reach their house, Mr. Robinson drives 32 kilometers at an average speed of 64 kilometers per hour. So here let's discuss the given of Mr. Robinson. So the distance that Mr. Robinson covers is d is equal to 32 kilometers. His average speed is given by Vm is equal to 64 kilometers per hour. While his wife drives 30 kilometers, so Mrs. Robinson she travels a distance of 30 kilometers and of average speed Vm is equal to 40 kilometers per hour. Now in 11.1 they are telling me calculate the duration of the man and that of his wives in hours, then in minutes. Okay, so here let me modify something in the question, and let's say calculate the duration in seconds. So let me remove this and say in seconds. Okay, so let's start by the duration of the man. So knowing that d is equal to 32 kilometers, knowing that kilometers is not the SI unit of distance, in order to convert from kilometers to meters, we multiply by 1000. So this is equal to 32 multiplied by 1000, which is equal to 32,000 meters. Vm is given by 64 kilometers per hour. In order to convert from kilometers per hour to meters per second, which is the SI, then we divide by 3.6. Then this is given by 17.78 meters per second. Now we are interested in determining the duration of the man, knowing that Vm is equal to d divided by delta t, knowing that we are interested in determining delta t using this formula. So constructing the triangle of this formula, here because we have divide, then Vm will be at the bottom, d at the top, delta t here. So putting our hand over delta t, then delta t is given by d divided by Vm. The value of D is given by 32,000. The value of VM is given by 17.78. So this is equal to 1,799.78 seconds. So delta T of the man is given by Now as for his wife, the duration of the wife, we know that D of the wife is given by 30 kilometers. In order to convert from kilometers to meters, we multiply by 1000. So this is given by 30,000 meters. Now as for the speed of the wife, which is given by 40 kilometers per hour, so in order to convert kilometers per hour to the SI, we divide by 3.6. So this is equal to 11.11 meters per second. Now after we have converted T to the SI, Vm to the SI, we are ready to calculate the duration of the wife, knowing that the duration is given by delta T is equal to D divided by Vm. So 30,000 divided by 11.11. Then this is given by 2,700.27 seconds. So delta T is equal to 2,700.27 seconds. And let me say that this is delta for wife, delta T for wife. Now in 11.2 they are asking me who arrives home first. In order to determine which of the two arrives home first, we need to compare the duration of both. Knowing that delta Tm is equal to 1,799.78 seconds, whereas delta T for the wife is equal to 2,700.27 seconds. So by compare, it means that we need to state whether delta Tm is greater than delta Tw, equal or less than, and in this case the duration corresponding for the man is less than the duration corresponding for the wife, which means that the man takes him less time to arrive home than the man arrives first. Now in 11.3, for how many minutes does the first one to arrive have to wait for the other to reach home? So they are asking me about the difference in time. So in this case, let's calculate 2,700.27 minus 1,799.78. Why I am calculating this difference? They are telling me for how many minutes does the first one to arrive have to wait. So knowing that the Mr. Robinson arrives at for this duration, he needs to wait for a difference of this minus this in order for the wife reaches home. So it's simply the difference between these two numbers. Then we can use the calculator to calculate the difference. Then the difference is given by almost 900.49 seconds. But they are telling me to calculate in minutes and not in seconds. We know that in order to convert from seconds to minutes, we divide by 60. So 900.49 divided by 60, this is equal to, so almost 15 minutes. The man should wait for 15 minutes in order for the wife to reach home. And now finally, the final exercise in this video is given by, or this part is given by exercise number 15, page 67. They are telling me speed and motion. A plane takes off from Beirut airport at 21 hours 05 minutes. It reaches Larnaca airport at 21 hours 25 minutes after traveling 210 kilometers. So always quantities in physics are referred by referring to their units. We know that kilometers is the unit representing unit of distance. So in this case, the distance separating Beirut airport from Larnaca airport is given by 210 kilometers. Knowing that kilometers is not the SI unit of distance, in order to convert from kilometers to meters, we simply multiply by 1000. So the distance separating the two airports is given by 210,000 meters. Now what about these? Do they represent instant times or duration? So because we have two times, then they represent instant times. So T1 is given by 21 hours and 5 minutes, whereas T2 is given by 21 hours 25 minutes. They are telling me to calculate the average speed of the plane. So first we will calculate it in meters per second, then we'll convert it to kilometers per hour. So by definition, Vm is given by d divided by delta t. In order to calculate Vm, we need to know d and delta t. D is already given in meters. Now we need to calculate delta t, which is given by T2 minus T1. Now T1 can be written as 21.0500, in which this represents hours, this represents minutes, and this represents seconds. And T2 is given by 21.2500. So this is equal to 21.2500 minus 21.0500, which is equal to 00.2000. So this is equal to 20 minutes. Now in order to convert minutes into seconds, we multiply by 60. So 20 multiplied by 60, this is given by 1800 seconds. So the duration delta t is 1800 seconds. Sorry, 1200. Now we know the duration and the SI, we know the distance and the SI. We are ready to calculate Vm. So Vm is given by 210,000 divided by 1200. This is equal to 175 meters per second. So Vm is equal to 175 meters per second, but notice that they are asking me to calculate the average speed in kilometers per hour. In order to convert meters per second to kilometers per hour, we simply multiply by 3.6. So 175 multiplied by 3.6, this is equal to 630 kilometers per hour. So Vm is equal to 630 kilometers per hour. This is the average speed of the airplane moving from Beirut airport to Larnaca. So that's it for me in this video, guys. In the next part, we'll complete solving exercises on this chapter.